Section 4.3 is entitled Solving Quadratic Equations by Factoring. In the last section we looked at solving quadratic equations by graphing, and what we did was we graphed the related function and found where it crossed the x-axis. Many quadratic equations can be factored, and sometimes that's a little easier than graphing. So recall that a quadratic equation is in the form ax squared plus bx plus c equals 0. Now its factored form is the following, and this is going to look a little strange. Don't worry too much about it. A times the quantity x minus p times the quantity x minus q equals 0, where p and q, those are numbers, and those are the two roots. Those are the x-intercepts of the related function. In other words, the solutions are x equals p and x equals q. So let's do a little problem where we work backwards on this. Let's write the quadratic equation whose roots are 3/4 and -5. So what does that mean? That means that x equals 3/4 and x equals -5. So to write the quadratic equation, I'm going to subtract 3/4 on both sides, or subtract 3/4, okay, and add 5, and make that equal to 0. That's my quadratic equation there. So I need to kind of put this into a little bit different form that looks a little more familiar. So I'm going to FOIL. That'll give me x squared minus 3/4 x plus 5x minus 15/4 equals 0. And that looks a little messy, so let's go ahead and multiply the whole thing by 4 to get rid of that pesky denominator. So that's going to give me 4x squared minus 3x plus 20x minus 15 equals 0. And now combining like terms, 4x squared plus 17x minus 15 equals 0. And that is the quadratic equation that has as its two solutions x equals 3/4 and x equals -5. Recall that to solve an equation by factoring, we need to use something called the zero product property, which basically says that if you multiply two things and you get a 0, then either the first one is 0, the second one is 0, or both of them are 0. So if a times b equals 0, then either a equals 0, or b equals 0, or both a and b equals 0. So that means if the quantity x minus 3 times the quantity x plus 5 equals 0, then we need to say that x minus 3 equals 0 and x plus 5 equals 0. This is going to be an important property to use when we go to solve quadratic equations. So let's review a whole bunch of factoring techniques and different ways you can factor polynomials. The first one, and probably the easiest, is factoring using the greatest common factor. And that's basically the distributive property backwards. We're going to undistribute. So given 9x squared plus 3x, we need to ask ourselves what is the biggest value that goes into both of those terms. In other words, look at the coefficients. What's the biggest number that goes into both 9 and 3? And then looking at the variables, x squared and x, what's the biggest power of x that goes into both of those? So that's going to be a 3 and an x. So I'm basically going to undistribute a 3x from each of those. So basically 9x squared divided by 3x gives me a 3x and a plus 1. So the easiest way to know that you did this right is to check by distributing. If I do 3x times the quantity 3x plus 1, I should get back where I started. 3x times 3x is 9x squared. 3x times 1 is 3x. So factoring by using the greatest common factor is basically undistributing. Let's do that to solve this equation here. 20x squared plus 15x equals 0. First step is to factor the left-hand side of the equal sign. What's the biggest number that goes into both 20x squared and 15x? I think that's going to be a 5x so that will go outside the parentheses. And now I need to figure out what's left. What do I have to multiply 5x by to get 20x squared? That would be a 4x. And then what do I have to multiply 5x by to get 15x? That would be a 3. Now I use the zero product property because I have 5x is one quantity times 4x minus 3 is my other quantity. So I need to take into account that 5x could equal 0 and 4x plus 3 could equal 0. So solving each one of those equations, x equals 0, and then subtracting 3 on both sides, and dividing by 4, x equals a negative 3/4. Another way to factor is to factor trinomials where a is equal to 1. That is, the coefficient of x squared is 1, or you're just not going to see a coefficient there. So the method for doing that is to find two numbers whose product is whatever c is and whose sum is b. So given x squared minus 7x plus 12, I need to find two numbers that multiply to 12, and the same two numbers have to add up to a negative 7. Two numbers whose product is c and whose sum is b. So here's where it really helps to know your times tables. I'm thinking 3 and 4, but they've got to be, I sometimes just like to put the numbers in here. And that works for the first equation, but it doesn't for the second one, because 3 plus 4 is not negative 7. But if I do a negative 3 and a negative 4, that actually works for both of those. Here's the cool thing about that. Those go directly into the parentheses with x's. So x minus 3 and an x minus 4. And that's how you factor that. Not too difficult if a is equal to 1. Here's an equation to solve that uses that method. I need to solve x squared minus 2x minus 15 equals 0. So my first step is going to be to factor. I need two numbers that multiply to negative 15. Same two numbers have to add up to negative 2. I'm thinking of 5 and a 3. And it doesn't matter which one you put first, but I do have to have one of those negative in order to get a negative 15. But in order to get a negative 2, my 5 is going to have to be negative. So I will put negative 5 and positive 3 into parentheses. So I've factored the left-hand side of the equation. And now I need to solve this. Set each one of those equal to 0. So x minus 5 equals 0. X plus 3 equals 0. Solve each one of those. X equals 5. And x equals a negative 3. The next method we're going to look at is factoring trinomials where a is not equal to 1. And this is a little more complicated. One way you can do this is guess and check. I'm not really a big fan of that. I don't have the patience for that. I'd rather go through a method where I know for sure I'm going to get the right answer the first time. So I am going to find two numbers whose product is whatever a times c is. Not whose product is c, but a times c. And their sum is b. And then I'm going to use the method of factoring by grouping. So let's take a look at this example. 6x squared plus 7x minus 3. So I need two numbers that multiply to negative 18. That's 6 times negative 3 gives me a negative 18. And then those same two numbers have to add up to a positive 7. So I'm thinking probably like 9 and 2. To make my second equation true, it's going to have to be a negative 2. So 9 times negative 2 is negative 18. 9 plus a negative 2 is 7. So now I'm going to use those two numbers. I'm going to use the 9 and the negative 2 to rewrite my b. So I'll have 6x squared plus 9x minus 2x minus 3. Notice what I did was when I found these two numbers, the 9 and the negative 2, I used those to rewrite this positive 7. So this is basically the same equation. I just kind of or same polynomial. I just kind of rewrote the middle here. Now I'm going to do factoring by grouping. I'm going to put parentheses around the first two, parentheses around the last two, and I'm going to grab the negative in front of the 2 and put a plus up here. Now I'm going to look at each set of parentheses and take out a greatest common factor. So given 6x squared plus 9x, I can take out a 3x, and that leaves me with 2x plus 3. Out of the second one, I can take out just a 1, but since there's a negative here, let's make it a negative 1, and that's going to leave me 2x plus 3. Now if you're doing it right, you should have the same stuff in the parentheses, in which case I do. So now what I do is I basically factor out of each of those terms a 2x plus 3, or the easy way to think of it is take these two, I like to call them lonely boys, sitting out front, the 3x minus 1, put those together, and then we have our 2x plus 3, the repeated factor. And that's factored. And actually, if you need to check this, you would just FOIL it and you should get back to the same thing. Let's use that to solve an equation here. I have 12x squared minus 2x minus 2 equals 0. So I'm going to start by factoring by grouping. I need two numbers whose product is negative 24, and I got that by doing 12 times negative 2, that's a times c, and the same two numbers have to add up to the negative 2 that's in the middle. And I'm thinking like a 6 and a 4, and I know one of those has to be negative for it to get a negative 24 when I multiply, but then to get a negative 2 when I add, my 6 has to be negative. So I'm going to use that negative 6 and that positive 4 to rewrite my negative 2 in the middle. So 12x squared minus 6x plus 4x minus 2 equals 0. And it doesn't matter which one you put first. I could have put the 4x before the negative 6x. It really doesn't matter. Now I will parentheticate and factor by undistributing. So here I can take out a 6x, and that leaves me with a 2x minus 1. Here I can take out a 4, no, not a 4, I can take out a 2, and that will leave me a 2x minus 1. This is looking really good because I have the same thing here. And so I'm going to take my two lonely boys, put those together, and then my repeated factor. Now I'm actually noticing something, that my first set of parentheses here, 6x minus 2, I could actually take a 2 out of that. If I were just factoring, not solving an equation, not trying to find x, just factoring, I would have to do that. But it's actually going to work itself out when I go to solve this. So take each of those and set them equal to 0 and solve for x. So 6x equals negative 2. And dividing both sides by 6, I get negative 2 over 6, which is the same as negative 1/3. That's where that dividing out would have simplified that a little bit, but it's not too bad. Add 1 to both sides, and divide by 2. So x is equal to negative 1/3, and x is equal to 1/2. Our next factoring method is when we have to factor a difference of squares. This is actually one of my favorite. So if you put a squared minus b squared, it breaks down into a plus b, a minus b. So basically you're going to be looking for a perfect square, first of all, a minus in the middle, and then another perfect square. And then you'll take the square root of what those things are and just kind of pull it apart. So factor 25x squared minus 36y squared. I'm noticing that 25x squared is actually a 5x and a 5x. That is a perfect square. 36y squared is a 6y and a 6y. And there's not a whole lot of work to do here. I'll just take a 5x and do plus 6y, and then a 5x, and then a minus 6y. And that's all there is to it. I think I like this one because there aren't really many steps. You just have to recognize that you've got a perfect square minus another perfect square, and then just kind of pull those perfect squares apart, do one plus and one with a minus. So let's solve the equation x squared minus 81 equals 0. And this is a difference of squares because x squared is x and x. 81 is 9 times 9. So this is going to factor into an x plus 9 and an x minus 9, which means x plus 9 equals 0, x minus 9 equals 0, so x equals negative 9, x equals a positive 9. If you want to look really sharp, you can write it like this: x equals a positive or negative 9. And the last type of factoring we're going to take a look at is factoring a perfect square trinomial. Okay? In other words, this is a trinomial, a polynomial that has 3 terms, that can be factored into something, a binomial, times itself. So, a squared plus 2ab plus b squared can be factored into a plus b quantity squared. Same thing with subtraction. A squared minus 2ab plus b squared can be factored into a minus b quantity squared. Now, the trick to this is kind of recognizing what a and b are. So I'm noticing that 9x squared is a perfect square. It's a 3x and a 3x. 16 is also a perfect square. It's a 4 and a 4. Now, the pesky part is this middle term right here, this 2ab. So is my middle term 2 times one of these times one of these? 2 times 3x times 4 is indeed 24, so this is a perfect square trinomial. So it will factor into a 3x in the parentheses and a 4 in the parentheses, and because there's a minus here, we have a minus there, and it is squared. And that's just a little shortcut. I mean, you could do the whole factoring by grouping things, 2 numbers that multiply to whatever 9 times 16 is and add up to 24, and work through the steps of that. But if you recognize that a trinomial is a perfect square trinomial, that it meets these criteria, it's very easy to factor it like this. Let's take a look at an equation that uses a perfect square trinomial. This one's a little easier. So we have x squared plus 6x plus 9 equals 0. X is a perfect square. I'm sorry, x squared is a perfect square. 9 is a perfect square. Now, is the middle term 2, because there's always a 2. Remember in our little formulas up here, there was a 2 in front of the AB, times one of these, times one of these. And indeed it is. 6x is 2 times x times 3. So this is a perfect square trinomial, and it will factor into x plus 3 squared equals 0. Now remember what that means is that means x plus 3 times x plus 3. We have the same thing twice. So we don't really need to write it out twice. We just need to write x plus 3 equals 0. So x is equal to negative 3. So this is a case where you have only one solution. And remember from the last lesson, if we were to graph the related function, if I were to graph f of x equals x squared plus 6x plus 9, that graph would touch the x-axis in only one point, where x equals negative 3. So a lot of different factoring techniques to use. Go back and rewatch this video or certain parts of it if there's something that you forgot or are having difficulty.